I'm the Director of Network Operation and Intelligence at National Grid Electricity Transmission, which is quite a mouthful. So my role involves the 24/7, 365 operation of the high voltage transmission system in England and Wales. And then the intelligence part is a theme that you'll see, and I'll talk about a bit as we get there, which is understanding the intelligence and the insights that we get from that network and how we can use that on a forward-looking basis to not only evolve the grid, but operate it much more intelligently in real time and manage our operational instance as we go. So I think whilst this is a focus forwards, I was just going to reflect a little bit. I've been at National Grid 20 years, and when I started at National Grid, I worked as a power system engineer, and we were getting one application every couple of months, and very rarely they would be interactive with another. You look at that now, and we're seeing over a gigawatt, in the region of a gigawatt a day, and then there's a total of 700 gigawatts of generation in the connection queue in GB, if you combine transmission and distribution. So a huge change that we've seen. If you look at demand was very much what we call a diurnal profile. Certain peak in the morning when we wake up, it would tail off in the middle of the day, and then it would peak again when we get home. We turn the lights on, we turn the ovens on to cook our dinner and things like that. Those profiles have now changed. We're not seeing the increases, we're seeing behaviours change, and we're also seeing embedded generation, meaning that we're seeing now some of our grid supply points getting close to exporting when it's windy or when it's sunny, and in particular when the demand is low, so sort of middle of the day, middle of the night, sorts of period of time. And I think the other thing, which is just as a general consumer in society, we have made choices ourselves as to when we turn things on and off. But when I go home and I plug my car in, I don't decide when to charge the car. In fact, no human does, a computer does. So we're seeing a start of a movement, I guess, away from human choices and more to computer choices or connected grid choices, which is again a theme which I'll pick up as I go through. So very quickly, National Grid. So some people refer to the National Grid. So I'm just going to myth bust a bit. So National Grid Group, as a group, we made a strategic pivot in the region of 2 years ago away from gas to majority electricity. And that business is across the UK and the US. If we pick on the UK, there are three network really components to that. One is electricity transmission, which is the bit of the business that I work in. We've then got electricity distribution, with electricity distribution taking it from the transmission system at 132,000 volts down to our homes, our offices, and the pipes and wires that go through our pavements to where we reside. And then we've got National Grid Ventures, which is the commercial arm or the commercially regulated parts of National Grid Group. And in the UK, that's the Grain LNG terminal at the Isle of Grain, and the interconnectors, which are subsea electricity cables between here and 5 different countries in Europe. So a little bit more about electricity transmission. So electricity transmission is typically 400 and 275,000 volts. And that is a system that is connecting large-scale generation to the distribution networks. And the National Grid component of that is in England and Wales. And that consists of, in the region of 4,500 miles of overhead lines, often referred to as pylons or towers, and then 900 miles of underground cables. Jordan earlier on referred actually to the reliability and the availability of the grid, and it's something that we're incredibly proud of. The figure you see there is a figure from 2017-18, and we often refer to that as 4 nines or 5 nines, and that's a consistent availability that we sustain on the network. As I say, we're very proud of it. And I think the one thing which I'd call out is, at the moment, we're reliant on electricity for typically light. But over time, as consumers and as industry, we'll be dependent on that for our transport. What if we have an outage in the middle of the night and our car doesn't charge? what if it's really cold and the heating system in our house isn't working? So that availability, that reliability of the network is going to be ever more important as the requirements or the demands on the electricity grid change over time. So we talk a lot about the challenges that we've got ahead of us, but we're not starting from scratch. In the last 20, 30 years, we've seen a huge amount of progress in the decarbonisation of the electricity system in particular. We're constantly seeing records tumble. We're constantly seeing new wind farms, new solar projects connected to the network. So anyone who's keeping abreast of social media, whether that's LinkedIn and industry press, or whether that's publications from the energy system operator, you'll see that these records are consistently being broken, wind records. And the one that you'll see in the top right-hand side is 2 weeks ago, actually, or just nearly 2 weeks ago, the carbon intensity on the electricity grid dropped to 19 grams of CO2 per kilowatt hour. The reason I'm looking down is that I'm checking my phone. So as of 6 o'clock this morning, that figure was 250 grams of CO2. So the point that's worth calling out here is that whilst we're making huge amounts of progress for periods of time, we need that reduction in carbon intensity to be sustained. So at the moment, we have, at 6 o'clock this morning, we have 5 gigawatts of the 25 gigawatts of wind available because of weather conditions. So whilst we're making a huge amount of progress, there is still a huge amount of progress to do, or a huge amount of progress to go as we keep those numbers down and we sustain that through the operation of the grid. So I think numbers and diagrams always speak volumes. So just calling out a couple of the targets, and again, Jordan mentioned the net zero, which we have generally talked about in terms of electricity, heat, and transport. So those are some of the things which you'll see on this slide here. So 600,000 heat pump installations per annum. I was having a look at the latest figures last night, and as of the end of 2023, we're at 200,000 total installed, which means that there's a tenfold increase needed per annum to get to this target. And again, you get to this target, and then that's a sustained delivery of 600,000 a year to get us to our decarbonisation targets. I won't mention electric vehicles. I'm sure people have seen and heard a lot about the electric vehicle targets. A fully decarbonised electricity system by 2035. That's something that our current government has set as a policy target. And earlier on this week, the Labour government were talking about their ambition for that date to be 2030. And I think it's fair that they also recognise that that is an incredibly stretching target. And they're openly acknowledging that the 2030 target, whilst challenging, sets such an ambitious target that the theory being that that ambitious target enables us to push harder, to test ideas maybe that we didn't think were possible, the end result being we get further than we had originally planned to. Just calling out some of the numbers on the right-hand side of the graphics there, you'll see the wind, solar and storage, big multiples of numbers in terms of the capacity. And those numbers, in fact, are only to 2035. And then interconnection, which is a key part of our grid structure, which is the connection from one network to another network. So whether that's a connection from the UK to France, to Norway, to Belgium, to the Netherlands. The main reason being that if it's in the middle of the night and it's windy, where's that power going to go? It can go to other places on a much more dispersed basis and get better utilization of the energy, and the low carbon energy in particular that's being generated onto the system. So I'm going to talk for a moment now about what that may look like, and I'm going to probably talk about it in things that we could possibly all recognize, either as players in the industry or as consumers and members of society. So I'll start on the right-hand side and talk about delivering for our customers. So I mentioned about the future home being dependent for light, being dependent for heat, and being dependent for transport. Can see a world where the vehicles will be connected at home. And in fact, you can already have a vehicle which is not only taking power from your home, but has the ability to give it back into the grid when the grid may call for it. So then the technology, the data flows, and the products with the suppliers are already there to enable some of this technology to happen. There will be a huge amount of insight that will be gleaned from consumers in their homes. This can then be used to predict behaviors, to predict supply and demand requirements, all in the aid of optimizing not only the investment, but the utilization and the operations of the grids and the networks that are delivering that energy to homes. If I work my way clockwise around the diagram, for me and for our organization as a network owner and an operator, understanding how we build, own, operate, and maintain that network, and do that underpinned by a huge amount of digital capability to understand how we manage our work, how we manage our workforce in the optimal way, how we're managing our assets in the most intelligent way. We need to make sure that we're maintaining the availability of that network, which means only taking out of service when we need to. I think historically we've talked about this as an efficiency aspiration. It's not only an efficiency aspiration anymore, it's an operational requirement to maintain your networks of the future. And you will only do that if you've got data points talking to each other. That's getting in front of the right people who can make the right choices to do the right things. So getting your data from your assets, turning it information and insight, and then turning that insight into action as an organization to make sure that you've got that asset working in the right and most appropriate way. I've talked about Great Grid upgrades in terms of the development and the investment needed on the grid, and I'll talk more about that shortly. But also when we're talking about the consenting process, talking about how we understand the data sets associated with what we're trying to build, where we're trying to build it, how it will come together alongside the different parts of infrastructure, using that in a way that can then be handed over into the operation of the asset. How do we make sure that we're optimizing what we're building? How are we automating, for example, the way that we assess route studies? We know that to deliver the investment required, there's a huge amount of supply chain demand. So whether that's supply chain demand for people or whether that's supply chain demand for materials, and this is a global challenge that we're addressing when we're talking about net zero. So getting the insight from the supply chain, understanding where and how the materials are coming in, what that means in terms of delivery and risk, and how we can take action in a proactive way. And then again, a theme which you'll see me talking about in a second, actually, is that you can't just operate a transmission system without distribution, without consumers, without supply from a generation perspective. So not only do we need to understand the data to manage the individual discrete parts of the total energy system, you need to make sure that all of that data talks to each other. So a real push for open data, data that can talk to each other, interact with each other, and get that information and insight that comes from it to make sure that we're transitioning our grid and our utilities in a collective way. There's some of the themes that you can see around there around, access to the market, to the systems, to do the work, doing it in an affordable way, because if we're talking about investment, that investment needs to come from somewhere. So doing it at the most economic and efficient way for consumers, for the people that are aiming to or will seek the benefit from the delivery. But I think the other theme here is that not all of these solutions exist. So we've constantly got to keep testing ourselves and driving innovative different ways of doing things. Another theme building on how that network comes together, or how a connected utility may come together, is that not one part of the sector will solve this. And in fact, there's a huge amount of interaction between different parts of that. So whole systems thinking is the theme. You'll see a graphic here from the Energy Systems Catapult that really nicely breaks that down into three distinct areas. So if we look at the energy system and you look at it right to left, if consumer behavior changes, peaks in demand won't be as pronounced maybe as they would have otherwise been. That means that the network investment to the further left-hand side doesn't necessarily have to meet those peaks, but it may have to be more flexible around what that may look like. That can then mean further to the right-hand side, the generation volumes may need to change. So all of those components of the energy system, right from when the electricity is generated right to the point where it's consumed, whether that's in and around a house if you've got rooftop solar, or whether it's the high voltage transmission system, understanding how all of that works and thinking about it in a connected way is what will really make a difference. We've spoken about electricity, heat and transport and the huge nature of their interaction. So let's just pick on hydrogen as one example that you can kind of use in here to illustrate what that means. Hydrogen could be used to heat homes. Hydrogen could be used for road transport. Hydrogen could also be used as storage. You can use excess renewable energy to create what's referred to as green hydrogen. That can then create that green hydrogen that can be stored. That green hydrogen can then be burnt through combustion, and you end up then thinking about hydrogen as storage for your electricity challenge. So that is just one example of how a whole system, whole energy way of thinking is required in order for us to get to our net zero outcome. And then, yes, we talk a lot about the things that need to be built, the processes that we need to develop. And I've talked a bit about the digital system that needs to underpin that. But that will only work if the market and the policy is there. I mentioned a couple of those policy examples, such as a decarbonisation target for electricity and the electricity market framework that needs to underpin that. The policy statements that may sit around transport and what that means. And also the, just picking on the digital system again, the whole vehicle to grid evolution, and that is now a very small part of the transport system that is doing that. How does that then rapidly grow and expand? So all of these things are interactive right across those lines, and I think it's fair to say that each of them are interactive with each other. But again, it's not something that we should shy away from. It's something that we need to lean into and tackle forwards. So these are stakeholder expectations. They are real stakeholder expectations. This is what stakeholders are telling us as a transmission network operator as we're going out to engage in what the next 5 years of network development would look like. I've mentioned affordability. Coming through a cost of living crisis, every pound that sits on a consumer bill matters. We need to make sure that we're delivering the whole energy system in the most economic and efficient way, and we're doing the highest value and highest return investments for the total challenge that we're collectively trying to address. I think sustainability is a theme in terms of achieving net zero, but also in terms of our operations. Some of the things that we do as a utility, and it's not just the national grid part, there's a huge amounts in the supply chain, for example, concrete. So we need to think about how we innovate and drive for lower carbon concrete. When we're decommissioning equipment, how are we making sure that we're recycling that equipment, reusing that equipment and putting it back into the development of the grid or somewhere else? So how are we sustainably growing a sustainable operation as an organisation? Mentioned about the importance of the electricity network, the reliability and resilience of that network. I think the thing which I haven't spoken about is resilience from a cyber perspective. So from the proliferation of digital and data and communication that's needed, we absolutely need to make sure that our assets are more cyber secure. And also that from a resilience perspective, we're seeing around the world changes in weather patterns, climate patterns, whether that's flooding, whether that's heating, whether it's extreme cold. So making sure that we're designing our assets of the future to match that, but also making sure that we're designing mitigations for the asset base that we've got today to maintain that reliability and resilience. It's absolutely of paramount importance to make sure that everyone who comes to work goes home from work, whether that's an employee of National Grid as an organisation, or whether that's a contractor that's working in National Grid as an organisation. I've mentioned National Grid, but that doesn't matter if it's National Grid, that's any organisation. So we need to make sure that the investments that we're making, the way that we're doing things, the way that we're transforming our business and collaborating is being done in a safe manner for everybody that works in and around the organisation, and of course the public that are in and around the investments. And I've mentioned availability as well. So yes, there's the resilience and the reliability to fault, and then there's the requirement to ensure that it's available when people want to use it, but also when the flows are coming. So my apologies for the background noise. That was the tannoy introducing the fire alarm where I am right now. I have tested the computer in the past and it doesn't pick up the noise, so hopefully that will not come through. So my final slide, I guess, and in the title, I've mentioned a couple of times around collaboration. Not one party can solve the net zero challenge. In fact, not one party has all the answers and the knowledge of how to do it. And we don't have all the answers yet, which is why innovation and really challenging ourselves in terms of how we're going to approach this is absolutely important. So from a skilled resources perspective, this isn't just about UK resources, this is global resources, because it is a global supply chain of people that we're talking about. So how do we make sure that we are developing the skill sets that we need to address the growth today, but also a sustainable pipeline of people for the future? How are we looking to higher carbon industries and developing the green energy jobs, or the green jobs of the future? So how are we supporting that green energy transition, and how are we engaging with organizations, and how are we developing our training and our attraction strategies to do that? As we deliver new technology, there will be new technology required to install and maintain that equipment. So this is where I kind of describe it as the life cycle of innovation, because just building something is no use if you can't maintain it. That's no use if you can't decommission it. And the whole life cycle consideration of how we install and safely manage, maintain, and commission our assets is something that we really need to make sure that we've got to focus on. I've spoken a bit already about the materials, and whether that's the raw materials going into it, or whether that's the factory slots to take those raw materials and turn them into the electrical network product. It's making sure that we're working collaboratively with the supply chain to identify where the pinch points are, but also to identify where and when we need to take intervention to make sure that that capacity is there for the future. Innovation and digital, we don't have all the solutions. We don't understand the art of the possible yet. We will only learn that as we experiment, but we have to take action. We have to take those bold and brave steps, and we have to work collaboratively with the recognition that we may not get it right every time, but we'll make a step forward, we'll learn, we'll go again. Policy and regulation, this is something that, as we're going through the development of as a regulated utility, and with the market being regulated in its own way, is working with policymakers to make sure that we are not seeing blockers in place for the evolution of investment in the network, investment in capability, investment in, or even collaboration or policy positions, if you like, in terms of how we collaborate across the sector on our data to make sure that we're delivering the overall right outcomes for consumers. So we're actively engaging a lot more, as I know a lot of other parties in the sector as well, to make sure that we understand what that looks like, and leaning in to help drive the changes in policy and regulation. I think the last point then is there's a huge amount of investment in networks, in infrastructure for supply and demand. And we just need to be really, really considerate of the communities that we'll be going into for construction, for assets that are there, and how are we collectively, as society, understanding what the transition to net zero means, and doing that in the optimal, economic and efficient way, not just for the communities, but for the bill payer that goes with that as well. So that's a whistle-stop tour through a number of the themes, but as I say, the easy answer is to kind of wait until we've got all the answers to all of these different things and then make that step change forward. So I guess as I close, my message would be that, we have a huge challenge in front of us. We need to work together on that challenge, and we need to take positive action forward in order to make steps towards it, and then keep an open dialogue as we learn and improve and drive that forward. So with that, we have a couple of minutes left for Q&A. So I will hand back to Jordan, and I will stop sharing my slides now. So thank you.
Perfect. Thank you so much, John. I will take a question from the audience first, and if anyone else in the audience has any questions, please do let us know. The first question is, how will the grid cope with the jump in demand for power from data centers as AI booms?
I haven't muted. There we go. So how would I respond to that? So I think it's fair to say that we're expecting demand to boom everywhere. You're absolutely right in calling out data, the amount of data that will be collected through all of those components of the digital utility, through all of the data centers that will be required to process that. And then, as you also call out, when AI comes in, it's then is it about the data storage, or is it about the computing power that's then going to start processing that? I think the interesting thing with that is you could look at that and say, actually, you know what, the demand for those is probably going to be higher in the summer because it will generate a lot of heat and you've got a lot of aircon load. And in fact, in the winter, their demand may well be lower because of the opposite effect of that. So if you look at that, you can say, well, if demand is higher for heating in homes in the winter, and it's high and it's lower for data centers, you've kind of got this equalizing effect. So this is where the whole systems thinking piece comes in to say, how will these different natured demands actually pull on their demand through the course of the day and through the course of the year? And how do we make sure that we're planning both the networks and the supply and also storage to meet what that looks like? So only working collectively with the industry to know what that requirement looks like and how it will work through the year will we understand how it really works. So whilst we don't have all the answers, I can say that the likely profile of them will nicely nest together to provide more equalizing effect. What that means as a network, though, is that your summer, when you think demand is lower and you've got more access to do more work, that assumption goes away. And it may well be that you're doing more work in the winter. So I think the nature of how we operate the grid will change over time, for examples, just like the one that's called out in the Q&A there.
And do you find that data centers are actually becoming more responsible energy users as it is with the installation of their own renewables, with energy storage? So they shouldn't, in the future, theoretically, because they have their own power systems, have that much of a demand on the grid as a whole. Is that what you're seeing, or?
I think the interesting thing there is a couple of things. One is supply prices. So in a world where energy prices are really high, there's a direct incentive financially on an organization to invest in generation in order to meet those requirements. You've also got social responsibility, that you're seeing organizations driving their own generation, their own green credentials there. But you've also got some projects that you're also seeing. So where I grew up in Swansea in South Wales, there's been talk of a barrage for some time. But the big challenge they had to that investment was getting financial commitment from the government. The current plan that they've got down there is for a barrage, a data center, and I can't remember the third thing that they were going to put there, but almost like a self-contained generation and demand production. It was possibly storage in one place. So you're seeing, I think, social responsibility, you're seeing economics, and you're seeing future development kind of incrementally move towards that way. but there will always be circumstances when that doesn't always work out in the geography.
And speaking more widely about energy storage, how important is that to the future grid? I know we've heard from some that the amount of time it's taking to install energy storage on the grid is longer than they had expected. Some given connection dates well into the 2030s. What is National Grid doing to improve that?
So that is one of the, if not the most significant focus areas for us at the moment, is how do we make sure that we are appropriately connecting customers to the grid. So we're working very closely with not only the distribution network companies, but also the what is in the process of being formed into the National Energy System Operator, to really understand some of the underlying assumptions, some of the modeling assumptions, some of the existing frameworks that sit around the modeling of the assets, and then making sure that we're undertaking those in the most appropriate way. So, for example, the planning assumptions associated with battery assume export from the grid at peak times, whereas we know from the market behavior, it's been observed that that will be a time when they're not exporting. They are behaving or acting differently in the market. So design assumptions have changed, and that has enabled further connection offers or further capacity to be made available to the grid. I think one of the challenges that was, I guess, possibly underestimated in the most recent review in the development of the two-step offer process was a huge influx in connection offers, or connection applications, I should say. And now it's a case of really understanding how we tackle the volumes in the queue, and that we work to get the projects that are, a term that's used, I suppose, shovel ready to connect to the grid. So working with different parties in the industry to make sure that we've got the right frameworks in place, working with our supply chain to make sure we're accelerating grid works as soon as we could, or as soon as we can, and then working on the frameworks to make sure that the right incentives to develop the right connection queue is a huge focus.
On that question, someone from the audience has asked, what type of reinforcement does the grid need to connect more battery energy storage?
What type of reinforcement does the grid need?
Yeah, that's the question.
Yeah. So I think, I think you've got two ways of thinking of storage, really. Is it demand or is it generation? The reality is it's both. It is because it can export when you need it to export, and it can take demand. So what's my main message there is that when we're moving the megawatts to where people want to need it, then the grid needs the capacity to do that. But likewise, the converse of that is the ability for the grid to bring it into where people need it. And as we're seeing demand patterns flow, I would say, yes, you've got the capacity element of what's needed across transmission and distribution there, but you've got the requirement for the flexibility. And you need to make sure that the grid is available and technically capable of moving that supply and demand around the network at pace. Because if you take interconnection, for example, which is connecting the onshore transmission systems of continental states, they can flow both ways within day in order to meet changes in renewable energy profiles. And that's a theme that you'll then see between transmission distribution as and when things move around.
Perfect. Thank you so much for joining us, John. And I will now let you go. Hopefully you don't have to get out of the building given that fire alarm. It was only a test.
No. Cool. Thanks very much. Have a good day.
Thank you so much.
Cheers, thank you.
All right, John.
Cheers. Bye-bye.
Thank you.